Hello class, Professor Anderson here. We just took a look at a problem where we tossed a rock up in the air and then it dropped into a hole, and we calculated how fast it was moving when it got to the bottom of the hole. And what we found was the final velocity was negative 28.7 meters per second, and we told you that the initial velocity going up was 25 meters per second. So let's ask a follow-up question here. How long is the rock in the air? So let me ask you guys. How long do you think the rock's going to be in the air, roughly? We said that you threw it up at 25 meters per second, right, which is about a 50-mile-per-hour throw, which is a pretty hard throw. So if you took a rock and you threw it straight up at 50 miles per hour, and it went up to some height, and then it came down a little bit further than you're standing, but only 10 meters, how long do you think it would be in the air?
7 seconds, 5 to 6.
Just raise your hand and then say it again.
Yeah, 4 to seconds, 4 to 5 seconds.
4 to 5 seconds? Yeah, that sounds pretty reasonable. I mean, if I throw a rock really hard, I can maybe keep it in the air for 4 to 5 seconds. I think that sounds reasonable. Anybody else have a different guess?
Just about like 6 seconds, I think.
6 seconds? Okay, sounds like we're in the same range there, between 4 and 6 seconds. So, how do we attack this problem? What do you guys think? What should we do next for this problem? Yeah?
Approach it with another kinematic equation, trying to solve for time.
Kinematic equation, solving for time. So we want to find a kinematic equation that actually has time in it. All right, let's try it. So let's go back to the first kinematic equation that we wrote. YF equals yi plus vyi times t plus 1/2 a sub y t squared. What we said was we know a lot of stuff in here. We know y final, we know y initial, we know vy initial, we don't know t, and we do know a sub y. So it looks like this equation will work, right? We can solve this for t. Now, do we want to solve this equation for t? Yeah, maybe not. Why?
A little more complicated than another kinematic equation.
Yeah, this is a quadratic equation, which is not complicated by a lot of standards, but it's more complicated than a linear equation. So let's see if we can figure out a different equation to use. And let's go to this one. V final equals V initial plus A times T. And now that we've done the first part of the problem, look what happens. We know this. We know this, and we always know that. And so the only thing we don't know here is time. And now this is a linear equation. We don't have to worry about remembering the quadratic formula. We can just solve this straight away. And it's not too bad at all. You guys know how to do this. I subtract vi from the other side. I divide by a sub y. And Bob's your uncle. OK, let's plug in some numbers and see what we get. Vf, we said, was negative 28.7 meters per second. Vi was positive 25 meters per second. And so we're subtracting that positive number. And then we divide by a sub y, which is 9.8 meters per second squared. But it is also in the negative direction. Okay, and now if you plug in all those numbers, you get 5.47 seconds, which is exactly in the ballpark that you guys identified earlier, between 4 and 6 seconds. So we like that answer a lot. Okay, hopefully that problem is clear. If not, come see me in office hours. Cheers.
Ooh.